Greetings. If you are using statistical control from any kind, you will most likely suffer from many false alarms. Why? This problem is caused because traditional statistical control does not always fit the need for water quality. In this short video, we will introduce you to a complementary concept called soft limits control. This short video will save you many hours struggling with false alarms of traditional statistics implemented to water control, as is. Let's refresh our memory about statistical control and how one may implement it for water quality control. Let's assume we are controlling the value of turbidity in a specific station. What we learn from history is what is the average value and what is the standard deviation. Given these values, we calculate the high statistical limit and the low statistical limit to be 3 standard deviations from both sides of the average. According to the statistical theory, this calculation assures us that for 99.7% of the time, we will be within limits. Given the above policy, we start to control the water quality, as shown by the blue line. And when the blue line crosses either the upper or lower statistical limits after proper delay time, bingo, we generate an alarm. Theoretically, it should work. Practically, we all know that such a control policy generates many false alarms. Why? This is because a system that monitors water quality 24/7 and generates a record every minute, 0.3% of 4 records per day, or 28 records per week, or 1460 records per year. Such an amount of alarms may be very annoying. So, what is the solution? The solution is soft limits control. What is the soft limits control concept? First, let's give this an acronym. Let's call it SLC, Soft Limits Control. SLC is the twist of the machine learning algorithm. It is based on the machine's ability to learn how many of the events of statistical limits violation matured into regulation limits violation. What about the slope and the past of the measurements curve made the events evolve into true positive events? Based on the sampling of some of our customers' sites, we obtained the following statistical table. 90% of the events which start with statistical limits violation end within a zone of 5 to 10% of the statistical limits. 8 to 9% of the events which start with statistical limits violation end within a zone of 10 to 25% of the statistical limits. Only 1 to 2% of the events which start with statistical limits violation matured into regulation limits violation. The last group of events can be identified by the slope and the curve's velocity after 5 to 10 minutes of statistical limits violation. How do we do that? We implement machine learning algorithms. The algorithm learns for each site, each measurement of the above table and adjusts the statistical limits control into soft limits control, which makes the lives of our engineers and customers much easier. If you want to learn more, please go to our website at www.mindset-tools.com or contact our technical support for possible implementation of our Mindset Detector software at your site.